Hello, everyone. Good morning, good evening, good afternoon, wherever you may be. My name is Daniel Moyer. I'm a sales support trainer here at Briggs Stratton Energy Solutions. With me today is Nathan Heston. Hello, Nathan.
Hi, Daniel.
Well, we got a new one for everybody today. I'm really excited about this one. It's off-grid living with SimpliPhi Power. This is a NABCEP accredited course, so we do have credits available to anybody who attends this talk. We're going to have our emails going to pop up at the end of this talk. Go ahead and email us your full name so we get it correct on the certificate of continuing education that we're going to issue to you. And after we check the logs, of course. And then also keep in mind that chat has been disabled in this talk. So if you have any questions, go ahead and put it into the Q&A chat feature, and either I or Nathan will address the questions during the talk, or we'll save a little time at the end to talk a little bit about it. So before we kind of get started into the content, I do want to remind everyone, NABCEP is coming up, the actual conference. It's going to be out in Raleigh. That's in, I think, just 2 weeks, and it's coming up quick. I'm actually going to be giving this talk, a little bit more expanded version of this talk at the conference. So I'm excited to be giving this talk there. This is going to be a great conference. It always is. Be sure when you bring your badges that you bring your pins from years past, because everybody likes to show off all their little pins that they've acquired over the years. Nathan, what are you going to be talking about?
So I'll be doing a talk on Solar 15K with SimpliPhi batteries, mostly centered around whole home backup and larger systems where you've got that 200 amp pass through. And Daniel and I both love this conference, and we'd like to see you there. It's probably the most engaging conference for us because it's all about training and learning and seeing new equipment and new things that are relevant to installers in the industry.
Yeah, and kind of a sneak peek, we are going to have a piece of our new equipment there as well. Really excited to be offering some of that new equipment. I'll show you here in just a second. We do, for those who are in California, I don't realize not everybody on this call is in California, but we do have some CPUC recognized batteries that are eligible for the SGIP. That's the Self-Generation Incentive Program. There's a lot of money available in this pool. They refunded the SGIP funds. So if you got somebody on a well pump, somebody on a medical device, somebody in I think a low-income area, there's money available. And even if you don't have some of that, there's still money available. Take a look
Farms
at
as well, Daniel.
I'm sorry?
Farms as well, right?
Yes, exactly. So some of our batteries do qualify for that. And take a look at that and get into it. This is the new product. I'm very excited to be announcing this new product. We're going to have our launch party at NABCEP. So if you do come, I believe the launch party, it's an after the conference event on Wednesday. Anybody on this call is invited to that. Stop by the booth, get your ticket, get information on where the after party is going to be. It's the 6.6. Each one of these battery stacks is 6.6 kilowatt hours. When you stack 3 of them together, you get right around 20 kilowatt hours, which is intentional because some of the NFPA requirements kind of cap you at 20 kilowatt hours per a single battery kind of module. Really excited to have this product. It's going to streamline the installation time. They stack together kind of like Legos. Not only the power stacks together, but also the communications. It increases installs, and the chance of installer mistakes are greatly reduced.
Daniel, we don't have dimensions there, but I can tell people. So we're going to have this at our booth at NABCEP. It's about 2.5 feet wide by a little over 5 feet tall, 20 kilowatt hour stack. So it greatly reduces the footprint and space needed to have this kind of power density there. Additionally, it's got a fairly high output as well. And so stay tuned for those details. We'll be releasing all the specs of this battery in 2 weeks.
Yeah, and I have it shown here with our inverter, a 6 kilowatt inverter with our Energy Track app. This is not the only inverter this battery can work with. We offer other inverter integrations, notably Solarc as well. So stay tuned. Thank you.
And if you do have questions about communications, it has closed loop communications. It is outdoor rated. So it's exciting for Daniel and I to be introducing this battery. Got a lot of the things we've been looking for over the years coming out in it.
Yeah, I'm really excited about it coming up in NABCEP. So Nathan, you had said whole home backup. Well, when we're talking about off-grid, we always have whole home backup, right? Because there is no grid essentially. And I kind of want to ground us and talk a little bit about where this industry started. Really, the first people in this country, and I would argue maybe even the world, that used photovoltaics and solar, besides maybe the space industry with their satellites, is off-grid remote homes, right? People kind of in the back to lander movements. And I went back and looked at some old home power magazines back in 2001, and I kind of pulled up this old ad, right? And what you see there is a Siemens 100-watt solar panel for $477. That's $4.70 a watt for a solar panel. That was crazy back then. We all know now that solar is less than 50 cents a watt, probably even less than that as well. And got some old pictures of an old trace inverter, some old solar modules, probably some old Arcos in there as well. But again, it was all started with the off-grid pioneers, the solar pioneers. And as we're talking through this slide deck that we're going to go through, I just want to indicate, there's so much more to living off-grid besides what we're going to talk about, which is batteries and solar, right? There's composting toilets, there's permaculture, there's rainwater catchment. There's so many other variables that make a off-grid living environment successful. And of course, we don't have the time to talk about it in this talk. But I don't want us to lose sight of what living off-grid can be. It can be a truly sustainable kind of environment. And I'm really excited to leverage our products to help that be successful. Another thing that I realized is that Briggs Stratton has been around a long time. In fact, it's been around a lot longer than 2001. We were started over 110 years ago, and we really had kind of innovative products. What you're looking at here is this gasoline-powered washing machine, really, that was used by a lot of rural Americans. So Briggs Stratton is a long history of a company. We're here to be here for the future, and we have a lot of resources and ability to kind of innovate going forward. So just keep that in mind when you're trying to choose a company to partner with. Great. You bought your cabin out in the woods, or maybe you brought a piece of property that doesn't have a structure on it already. So what are some of the cost factors that you think about when you're trying to run an off-grid system? Maybe you think about running the on-grid, right? Maybe you look at, well, where is the nearest utility service, and how much will it cost me to trench the conductors from the nearest transformer out to my property? Maybe you have to pay the utility company to add a transformer to the power lines. So it's not going to be cheap. But I will say this, that it's not going to be necessarily cheap to install a very robust off-grid solar system either. So when you're thinking about these cost kind of variables, you got to really consider it does cost a lot to do a trench and add a transformer, and maybe have to comply with right-of-way agreements and survey and permit fees. But it's also going to maybe cost a lot to do the off-grid system as well. So you got to balance those costs and recognize that it's not always going to be such a cut and dry. We're going off grid. Again, you look at those variables as well. This is a beautiful picture of a home up in Humboldt County, which is near Arcata, California, which is where I live, where a lot of the solar pioneers got their start as well. So we're going to quickly run through some of the types of off-grid systems. What you're looking at here is probably the most basic of the off-grid systems, is your kind of solar-powered radio and your solar-powered light lantern. One other thing I'm showing you here is our Jenny. We have a little Jenny and a big Jenny. And what these are kind of expeditionary kind of off-grid systems. And I kind of would put them into a different class than, say, the Goal Zeros or the Yetis. A lot of those Goal Zeros and Yetis are really designed to kind of be kept at the house and plugged into the wall and just kind of kept their battery charged. And if there's an outage, then you got this little box ready to go. Our Jennies, the big Jenny and little Jenny, are really designed to be expeditionary. What I mean by that is they're designed to go out into the off-grid environment. They're in these Pelican cases and really designed to be rugged and robust to give you that off-grid power as well. Another type of off-grid system is one that doesn't have batteries at all. So I'm not going to spend too much time here, but I just want to run through this because I want to make sure we understand these systems. A lot of times you don't need a battery, right? What we can do is use a solar panel to pump water uphill, and that tank of water, in essence, is your battery, right? And so what we can use is a pump controller, probably a linear current booster to run a pump it up the hill, up above your property, or maybe even in a water tower on the property. And then knowing that the height of that tower or the height of the hill is kind of analogous to the voltage, right? The pressure that you're able to see. So this is definitely systems that I've seen a direct voltage or direct PV to pump water. And also I've seen them done with wind or a fan as well.
Yeah, I've installed a number of those, Daniel, those sun pumps that are there. I've put a few in Ghana, West Africa, and did exactly what you said. And that pump controller that you're showing there is essentially an MPPT that maximizes that direct DC current. In the case of the ones I've installed, I've used 180 volt pumps, and absolutely, as you said, using direct DC off those solar panels to run those pumps.
Yeah, and I would also say, Nathan, is that this isn't in lieu of having also another battery-based system on the property as well. For example, you might be able to pump it into a water tank that isn't up on a hill, that isn't in a tower, and then you would have maybe a secondary booster pump that is being powered by a battery photovoltaic system to then provide that pressure as well. So
Absolutely.
yeah. Another kind of system, and this kind of reminds me back in I worked at Sunfrost, and I got some pictures of a Sunfrost here, refrigerators here in a little bit, is the ability to do DC microgrids. There's no inverter in this example. And back in the day, there were people that did this. They didn't have an inverter. They didn't have AC loads, and they were able to live just fine off the grid. What I mean by that is they have a DC light bulb, a DC refrigerator, a DC water pump, enough, maybe even to be able to charge up cell phones or laptops. Although I'm not sure how many people living in DC only systems had those kind of devices, but absolutely. And I want to point out here, what I'm showing you is a SunSaver MPPT charge controller. The photovoltaics is kind of being fed in on the left two terminals. The load, the batteries in the middle terminal, and then on the right terminal is the load out. And the reason it's a load out is that this is the version of this SunSaver that actually has a low battery, a low voltage disconnect, right? So if you happen to leave that light bulb on and the battery voltage drops below a certain percent or a certain voltage range, this SunSaver will actually open up that load out port and prevent the battery from being drained. But what I'm showing you is the refrigerator, either a Sundancer or a Sunfrost, is not being fed off that low voltage battery disconnect. It's actually being fed directly to the battery bank using some overcurrent protection there. And usually these fridges have the low battery voltage disconnect built into the compressor controller itself. And why I say that is that because refrigerators have a motor, a compressor, that a lot of times the surge amp draw of the motor in that compressor will exceed the 15 amps that SunSaver MPPT is rated for. Another thing down in the bottom left-hand corner is, this was a kind of a cool article I found from NREL. Don't want to go too deep into this, but they talked about in this article about how you can use Ethernet and USB-C kind of architecture to power DC loads. And with these new USB-Cs and the certain ways to new protocols with Ethernet, you can actually supply a surprisingly large number of watts over USB-C and Ethernet cables as well. This is we're getting a little closer to probably what most people are going to have. This is kind of a hybrid system where you have DC loads, but you also additionally have an inverter to run some AC loads as well. I'm still showing you that same SunSaver charge controller. I got a Morningstar pure sine wave inverter right there as well. I got a Midnight Solar combiner that's taking some of our Phi batteries and feeding up into supply these loads as well. Really though, I think this is kind of getting into what I think a lot of off-grid homes are going to be looking at is not necessarily any DC loads. What we're going to do is we're going to take a larger inverter, maybe like a Solar 12K, or even our inverter, our 6K inverter, and run a system with batteries, with solar, and then also add a generator. Because when you're living off grid, you don't have the grid to help support you in the dead of winter or in those cloudy days, right? So if I were to size, and we're gonna talk a little bit about sizing here in a second, but if I were to size your system, get you through the dead of winter, your solar photovoltaic array would be much way oversized than it would need to be in summer. So we're gonna try and find a balance, and then we're gonna leverage a generator to help get you through the dead of night and the long winter nights as well. One thing is that when we are thinking about living off grid, and I just want to say this, is that a lot of off grid dwellers rely on propane. In fact, propane is kind of the dirty little secret of living off grid. You can have a propane refrigerator where you boil, I think it's ammonia, and you use this Nathan, help me out here. It's a phase change of using propane. Really, you heat propane, using propane to heat ammonia to get a phase change to actually cool the fridge. You use
Yeah,
propane. Go
exactly,
ahead.
Daniel. And I've used one of those fridges. We had one of those at our farmhouse. So we had a disconnected farmhouse in off grid Africa, pretty far out in Ghana. What you're saying is exactly right. The propane is used to induce the phase, the separation of ammonia and water. And then when you recombine the ammonia with water, it creates a cooling effect. And so it's kind of surprising to many people that you can burn propane to create a cold refrigerator. But absolutely, it works. We just had a very hot kitchen because we exhausted that heat directly into our kitchen, which was typically in the 90s.
Yeah, and that's a good point. In the picture on the right, I'm showing you a wood stove. What if it's in the middle of summer and you got to cook food? Are you going to start a fire in your house and then be able to cook your food? So we're seeing a lot of people moving away from some of these things here. But again, propane has been used to cook with, to heat with, to hot water, domestic hot water, to running the fridge, and we see that. But again, there's opportunities to move away from propane now that we have some new technologies. But living off grid is not just kind of, a lot of people live off grid. They're going to want all the luxuries of living off grid. That's fine. But I would like to see people embrace kind of that more holistic off grid living, right? You're living out in nature for a reason, I would say. Do tasks during sunlight hours, right? Understand the seasonal variations, and make sure we educate the homeowners. Maybe a homeowner that's lived on grid their entire life now wants to live off grid. Help them understand that what you can do in summer is different than what you can do in winter. Make sure they understand if they start to add loads to the home that might affect the design that you spent so much time putting together. Make sure they just understand to turn off some of the loads and really check up with them, right? And maybe use a monitoring system like our Energy Track app from Briggs and Stratton, or maybe even Power View from Solar, and remote in and check to see, are they hitting low battery cutout every night in the winter? Are they getting that balanced system that you spent a lot of time designing? So really, with the advent of lithium-ion batteries, the ability to have a safe, reliable, very energy dense battery that has a lot of cycles in it, and solar being 50 cents a watt, you can really do away with the pedal washing machine and the wood stove as well. Of course, leverage these things if you want, and get away from necessarily some of those DC loads.
Well, I still want to get you one of those pedal washing machines for Christmas, Daniel. I think that would be a great gift.
All right,
a lot of
Nathan.
work.
Yeah. And again, but there's no dryer, right? Use a clothesline to dry your clothes as well. Don't use a propane gas powered dryer as well. So how are we going to do this, right? If you think about your home, on grid or an off grid homes, most of the energy consumed in the home goes to space heating and water heating. And how are we going to do this in an off grid home? One thing I always liked, and I had a great conversation with a solar hot water manufacturer recently, and I've always embraced solar hot water for the longest time, and it is solar hot water, right? You can use either evacuated tubes, or you can use those flat plate collectors to store it in tanks that can either provide domestic hot water, or we can run it through radiators, maybe through a heat exchanger, or even run radiant tubes in a floor as well to provide that heating for the home. But there is opportunities now to use heat pump water heaters you can take 1 unit of electricity and get 3 or 4 units of heat out of it. Whereas before you might only have had 1 unit of electricity equals 1 unit of heat if you had a resistive heater as well.
Daniel, that's a great point.
Yeah.
Hey, I wanted to just draw your attention to, there have been a couple of requests here for us to talk about load management a little bit later. And we will have an upcoming training with Lumen where we talk about using their 12 space load management panel with our equipment. But if you get the opportunity to touch on that later in this talk, Elliot would appreciate that.
Yeah, of course. And you know, I would argue almost load shedding is appropriate for an on-grid system that is going to be expected to go into a off-grid situation and drop loads. I would say that if you've designed a successful, properly sized, properly educated homeowner in an off-grid situation, you should really never need to drop any loads. Of course, we're still going to put in low battery voltage disconnects and take away the chore of a homeowner having to watch their app to see if their batteries are getting low and adjust their behaviors. But again, if we have a properly sized system and a generator that's able to be started automatically using a 2-wire signal to start, an off-grid system really shouldn't need any load control, right? It should be able to offer a home the ability to be an off-grid home without sacrificing any of things. If you are running into that situation where you are getting the low battery cutout voltage, or you're exceeding the ability of the inverter to provide power, I would argue that it's not a very well-designed system. Not to say that load control couldn't be leveraged in off-grid, but I see that more of an on-grid situation. Nathan, did you have any comments to add to that?
I'm checking to see if I'm muted here, but no, I don't, Daniel, although, you know, there might be times when you don't want that well pump to, you know, to take your system down if it kicks on unexpectedly. So there might be an opportunity to utilize devices like Lumen, and Lumen's come out with these individual units that can shed bigger loads as well. Yeah. So again, I'll defer to a later time period. There might be a time and place to use load management in.
Yeah, I think that's a great point. Absolutely, I think that's a great point with that well pump, right? So, or the water pump. So imagine that we don't want the well pump coming on in the middle of the night and draining your batteries. Why don't we program the load control to start the well pump in the middle of the day once the batteries are fully charged? We can go ahead and turn the well pump on because the batteries are charged, solar's still kicking, and we have nowhere for that power to go. Let's go ahead and start a well pump. So absolutely, that's a great example as well. For space heating, again, we could do a wood boiler or a wood stove as well, but a lot of times with these newer heat pumps, either air to air or air to water or air to ground heat pumps, that we can use these heat pumps to offer space heating as well. And a lot of these newer heat pumps have safer refrigerants. They have a better ability to work in colder ambient temperatures. They don't derate as fast. Of course, at some point, you're going to need an electric backup in these heaters as well. Nathan, this might look familiar, right? This is a structure. This is a system you did. And what I'm showing here now, this is a grid-tied system, notably, but what we're showing here is an 8.5 kilowatt system. And what you're showing us here is a kind of a graph of the production of this system. And what we're seeing is that in the middle of the day in March 25th, which isn't far from now, we're still in spring, technically winter, I think, that we're only getting maybe 5 kilowatts out of this array here. And why? And there's a number of reasons why we never will get the nameplate rating out of a solar system. Nathan, did you have something to add?
Yeah, I mean, you make a good point, right? I think you're going to talk about the orientation of the panels. A lot of the things can affect it. Pete adds here, and I thought it was worth reading, that it's important to educate customers about them adding loads down the road.
Yeah.
And this is something probably everybody's experienced. You give people access to cheap electricity, free electricity, and all of a sudden they want to use it, right? We had a meeting yesterday with a group that's going to be installing 1,500 of our batteries and microgrids in Senegal, and that was exactly what the utility that was there brought up, right? Is that, you know, customers start using a lot more electricity once they get access to cheap electricity. And so, great point, Pete. And thanks for sharing. Daniel, why don't you talk us through the different factors affecting solar panel output?
Yeah, yeah, of course. Whether or not the sun is shining, is it hitting the solar panel at a perpendicular angle? Temperature can affect that. In fact, the best day for solar would be a cold winter morning as well. A shading, of course, can affect that. The orientation, the maximum power point tracking, equipment inefficiencies, and inverter clipping, which I could spend a lot of time in talking about inverter clipping, but we're not going to go too deep into that now. Now, Nathan, you had kind of put together this diagram here, and I thought it was really interesting. So when we're living off grid and we have to harvest as much solar as possible, when solar was $4.70 a watt, a lot of times tracking the sun, either a dual axis or a single axis tracker, made sense. But now with solar being 50 cents a watt, it doesn't necessarily need to be that way. In fact, we can just add some extra panels to the array, knowing that we're not going to get the optimal irradiance from the sun, but that we add a few extra panels here. Now, I want you to walk us through this math here in a second, Nathan. But what I understand here is that if you got a solar panel pointing at the sun, right, perpendicular, you're going to get its whatever the full power is. And as you tilt the angle of the panel away, or maybe the sun is tilting away from the angle of the panel, the rate at which the power drops isn't linear, right? So we could get it off angle for a while, and then at some point it drops off rapidly. Please explain that to us.
Yeah, sure. And so the effective area of a panel, we use the term flux, and everybody's probably heard that term flux capacitor if you're old enough for back to the future. But the term flux just means kind of how much sunlight you're getting through a cross-sectional area that will strike your panel. Right. And so it actually, the effective area of the panel, if you look at the diagram I made there, and it's not great, but if you look at that diagram, only sunlight that's passing through the rectangle shown at the top will actually strike the surface of the panel. And the length of that one of those sides is just the length of the panel, but the length of the shorter one of those sides is the length of the panel, or the width of the panel, times the cosine of theta. And I don't want to get too into math, but the cosine of theta, for small angles is relatively close to 1. So there's a very small factor until you get to angles of about 30, 40 degrees, and then it starts to drop off more rapidly. And that accounts for that curve. You showed a curve earlier of the production of that that solar array that I put on that roof, where you get a steeper curve around 10 a.m. in the morning, and then you have somewhat flatter production throughout the day until the afternoon, and then late afternoon it starts to drop off quickly, and that it actually looks a little bit like a cosine curve, because that's what's affecting the amount of sunlight that's striking the surface of the panel. There's also increased reflectivity and other issues, but that's the biggest one here, of course, is the amount of solar flux that's striking the surface of your panel.
Thank you, Nathan. Yeah, and if we look at that tracker on the right, I mean, there's a lot of moving parts that come involved in trackers. I've always been excited about the ZoneWorks one, where they use refrigerant that I think boils off to one side of the panel that kind of tilts the panel to follow the sun as well.
Yeah, so I will say one thing about trackers, and I appreciate you spending the time to talk about them. It is fairly common to still see single axis trackers, right? Trackers that follow the sun east to west, especially in commercial grids, because it's not as hard to do as 2-axis tracking, and you don't have to have that much increased spacing between your panels. Yeah. If you're doing roof mount arrays, you might just add panels, but if you're doing ground mount, it might make sense to do a little bit of tracking.
Yeah, and I would argue, when we say tracking, does that mean that it tracks every day? Or maybe what we do is we have an adjustable solar array, so that in the winter we kind of tilt the panels up a little more to catch the sun that kind of skirts along the low on the horizon in winter, and then in the summer we can adjust the solar panels. So I think tracking is kind of that could be a whole talk in and of itself, Nathan, and maybe we should do that if people are interested in that. We don't sell trackers, so I don't know if we'll get the approval for that. But again, there's ability to track during the day, and like Nathan said, what axis are you tracking as well? And this kind of this slide here is just the kind of the takeaway here is if the batteries are charged, say by 1 o'clock in the afternoon, and the solar is still producing, there's no power flowing, right? So go ahead and start to do things in the house, like do the laundry, do some other, get the power saw, cut the wood, whatever you want to do, because use the power that's available if it doesn't have anywhere to go. And this brings me up to another point is I believe we're going to start to see more people who have the ability to be grid tied go off grid because of some of the net energy metering policies that are being kind of forced onto us from utility companies. So in California, for example, we just got NEM 3.0, where it doesn't make sense to export to the grid because you're getting paid pennies on the dollar for your kilowatt hours. So in a way, if you're not able to send it back to grid and it doesn't make sense, store it in batteries. So really this off-grid living with SimpliPhi can easily be applied to somebody that is living on grid. And frankly, if you're living on grid and you need to buy a little power in the middle of the winter, that's fine. Let's go ahead and import some power from winter. Quickly run through some sizing here as well. How do you, so you bought your off-grid house, great. You got a cabin, for example, and then we're going to talk about a smaller cabin. How many batteries do you need? How many solar panels do you need? For first, you got to think about how much power you're going to use. Then we're going to figure out how many batteries you need, figure out how much solar you need, and then make sure we choose an appropriate charge controller and inverter, and think about some of the wiring in the system. Kind of this, what we're showing on the screen is our access system. This is this kind of spoiler, this is the system we're going to use essentially. This is our 6K inverter. What you see down below are 6 3.8 kilowatt hour batteries. We can also put a solar 12K in this cabinet for you as well. Comes almost pre-wired with the bus bars and everything you might need. So we have calculators, so I'm not going to run through all of this here, but again, my cabin, my dirty little secret is going to be propane. So I'm not going to have any accounting for space heating, water, cooking, and I'm going to have a generator as well. So what we want to look at is how many kilowatt hours per day I use. In this example, I use 4.6 kilowatt hours. And I also need to know how much continuous AC output is going to be required and how much surge AC output is going to be required, because I have a water pump and I have a refrigerator that both have motors in them as well. So I told you that I'm using 4.6 kilowatt hours a day. I know there's a little bit of inverter inefficiencies, so I'm going to account for that. And I'm also going to account for, I want to make sure I can go about 3 days. So a lot of times we get clouds, we get rain. After about 3 days, usually the storm is going to pass and the sun's going to come back out. So I'm going to give me 3 days of autonomy. I'm also going to make sure that I don't discharge my batteries all the way. You can actually discharge our batteries down to 100%, use all the juice in our batteries, and we're still going to offer a very nice warranty. I'll go over warranties here in a second. But I'm going to actually discharge them just down to 80% so that I get a lot of cycle lives. In fact, if you discharge our batteries down just to 80%, you get about 10,000 cycles expected out of our batteries. So once you account for that, really, I need about 19 kilowatt hours to have that 3 days of autonomy, 80% depth of discharge, and make sure I get a little inverter inefficiencies. 19 divided by 3.8, which is the kilowatt hour rating of our batteries, is perfect. 5 batteries is what I need. Now we need to figure out how much solar panels we need. One thing to figure out how much solar panels you need is you got to figure out how much sunlight you get for wherever the area you might live. NREL has developed these awesome maps here. This one is showing you the average for the year solar that you'll get sunlight hours. And we could spend more time on that, but just realize that that's how many hours a day you're going to get full sun. This wouldn't be appropriate for an off-grid system. This would be appropriate for a grid-tied system that you can use the grid as your battery for the entire year. But if we're doing off-grid, we want to look at the worst month of the year. And that, in fact, this map behind me is very similar to the one that I'm showing here on the screen. This is showing the amount of sunlight hours you get during the worst month of the year. And I actually found this map in an old AEE catalog. I don't know if anybody still remembers that. They created these great catalogs that had a lot of tools in them. But we need to look at the worst month of the year. And maybe we, again, because we have a generator, it might be possible to not quite get this bad, but we're going to go ahead and go with this as well.
So Daniel, what contributes to the worst month of the year, and why would you look at the worst month of the year?
Well, because the worst month of the year, right, is in winter in the northern hemisphere, so the sun is very low in the sky. It also contributes to, so there's, not as many sun hours, right? The sun isn't up as much, many hours. It's also coming in at a lower angle, and also, frankly, weather, right? We get a lot worse weather, and so NREL has these stations. I think that they've been studying these stations. Maybe you can speak a little bit more to this, but this is very valuable data as well. And I'm sorry, was there another question?
No, I was just laughing at one of the ones that came in. They were asking for the map for Canada, and you've put it up there, which was good timing on your part. Yeah, you made a good comment earlier about, when that sun is low in the sky, typically in the winter for us, have that solar array, especially if it's a ground mount array. It's not as easily done with roof mount arrays, but have it be able to tilt towards the south so you can catch more of that direct normal radiation.
Yeah, and so part of this talk, like I said at the top of the hour, is that I'm going to be giving this talk in Raleigh coming up. So what I'm going to choose, I'm actually going to choose to design this system for Raleigh. Well, if you were to do an off-grid system, say outside the city, and so what I'm going to choose is 4 hours of peak sun hours a day for this design we're going to come up here with in a second as well.
So Elliot says, there's some text you'd recommend for reference design and sizing in off-grid systems, and I know you're about to get to that. Kathy wrote one that I wasn't following here. It says, I expect that V2X will replace at least some of the need for a generator. Is your inverter able to integrate V2X? And if not, will it be able to in the near future? I wasn't sure what V2X meant there.
I think it's maybe vehicle to grid.
Vehicle to grid, maybe. Or
Yeah.
vehicle to home, I guess the X there is probably a variable. So sorry, Kathy, for butchering your question. But exactly. So could you use vehicle to power? I'm not sure we're there yet. Daniel, you might be more informed. But
no, and I think that's going to be a huge part of the future is how do we leverage the batteries in our vehicles to help support the grid, and whether that's just backing up the home, whether it's time of use arbitrage. I do know this, that all batteries have a finite number of cycles in them. And there's a lot of, this is the Wild West, people. And I'm really excited for everybody on this call, because we're really at a cusp of an energy revolution of distributed assets, batteries on homes, batteries in vehicles. So again, we're there. In fact, not a lot of people's inverters do vehicle to grid. So it's coming out, it's getting there, and we're going to be there when the time is right. Nathan, did you have anything to add to that?
No, it's a great question, and I think for those that are in off-grid, it's a particularly interesting question, right? Because that is a big battery. I had somebody who actually bought some solar panels from me recently, and she drives a Tesla, and she's fairly far from charging stations, and she wanted to install solar and an inverter in order to be able to charge her Tesla in the off-grid situation as well.
Maybe.
And I think it's a big question, right? Whether or not vehicle manufacturers are going to want to allow discharge, and some of them already do. And I'm embarrassed that I didn't catch that V2X as I went to a talk last week on vehicle to grid.
Yeah, that's an awesome vehicle to whatever it may be.
Right.
That's I think we could spend a lot of time talking about vehicle to grid, and that's going to be a conversation that we're going to increasingly have more and more. What does that architecture look like? Does anyone still use the Solar Pathfinder? If you do, please put it in the chat, because I want to make sure that people are still out there doing this. There's Solmetric Suneye. There's programs from Aurora. There's programs from Open Solar that you don't got to get up on the roof and get your. But I really like the.
Well,
Solar
Jeremy
Pathfinder.
Said he does, so at least you've got at least some of us.
Yeah, because I like to do it, and I never get the homeowners up on the roof. But sometimes I'll put the Solar Pathfinder out there in kind of in the front yard of where the solar array will be. And it's such a great visual tool, because I can say, look, if you get your tree trimmers to cut down this tree, you know, you're going to get so much more solar access. And if anyone hasn't used one of these, each one of these essentially is showing the path of the sun in the sky for a given latitude, and you get this thing pointing directly south. And then you can add up these numbers along these arcs to give you the amount of percent of solar insolation that you would receive at a site. So
Daniel, I want to get a couple of comments in here. So John says that he usually discourages roof mounts for off-grid unless it's for extra power for air conditioning / summer refrigeration. A number of people here are commenting that vehicle to grid or vehicle to home is pretty much there. There's a company called Fermata that's already doing that, I guess. Steve says some hybrid vehicle to grid or vehicle to home is intriguing since the car can be used as a generator as well. Jeep Cherokee is an example. Yeah, John was also saying that he does it. Yorkie does. A number of people are using these Pathfinders. So you're getting some good feedback on that. Definitely do. Jeremy says our guys use them in Vermont, New Hampshire. They use the electronic version of this also.
Yeah. No, it's also, and those ones that have the software and then printed out. So absolutely. I'm glad to hear some people still doing that. And well, back to our design. Remember, I told you I used 4.6 kilowatt hours a day was what we were using. There's some battery inefficiencies, and I'm actually going to increase the size of the system by about 40% to account for the tilt, the shade, and system efficiencies. And remember, I told you about Raleigh, where I get about 4 sun hours. What the math works out to be is about 2 kilowatts. So if I have a 2 kilowatt array and I put it out in the sun for 4 hours, I will generate 8 kilowatt hours. Well, I just told you that I'm only using 4.6 kilowatt hours. That's because of system and shade inefficiencies and battery inefficiencies as well. So that's the size system. I would probably even up that a little bit, maybe even double that just to get us really robust, but that's what we're going to do. We got 2 kilowatts of solar. We need to make sure we have an appropriate charge controller that can handle that. I think an Outback charge controller would work great. I'm showing you on the left there some Outback charge controllers, Outback inverters, the Mate 3S, the automatic generator start. All of those parts and pieces can now be accomplished by a hybrid inverter. And I'm showing you our 6K SimpliPhi Power Briggs Stratton 6K inverter on the right-hand side. Either one of these options would be perfectly acceptable for what our system is going to be. What we did is, and a lot of people are doing the hybrid inverters now. You know, I look at Solark as well. They're taking all these parts and pieces and putting it into one box essentially. And what we do that is we're able to simplify things. But I don't care if you guys like doing the old, I would say old, the tried and true method of having separate components. Our batteries can support that. Our batteries can also support hybrid inverters, and we have integration guides that tell you how to program the Magnasigns, the Outbacks, all of the Victrons, all those different pieces of equipment can absolutely work with Briggs & Stratton SimpliPhi batteries as well. Now we need to make sure, so that's kind of the idea of the inverter. We need to make sure that our inverter can handle the continuous watts and also the surge watts available. And our inverter is definitely capable of doing that. Even that Outback was too, because right, we had that refrigerator that had a motor, and we had that well pump that had a motor. So there's that power factor associated with that. And so I'm showing you kind of the toaster versus those power tools that you see there on the right. There's my Sunfrost. So I actually worked at Sunfrost Refrigerators. I started back in 2008, which is a long time ago. And Sunfrost made refrigerators that had DC compressors. And our competition was those propane refrigerators. And whenever we would size these Sunfrost refrigerators, they used only about half a kilowatt hour a day, when most fridges at that time were using about 2 kilowatt hours a day. We would have in our documentation for installing a Sunfrost fridge what the appropriate conductors were. So this Sunfrost fridge uses about 10 amps. And if you were just to kind of think about 10 amps, a lot of people think 10 amps might be appropriate for, for ampacity's sakes, a 14 gauge wire can handle 10 amps. But if you start to get too far away, what starts to happen is voltage drop. So we don't see voltage drop really being a concern in 110 or 220 volt systems. But when we're doing lower voltage, like 24 or even 48 volt systems, and we're having DC loads, voltage drop starts to become a concern faster than ampacity becomes a concern. So really, if we have a fridge that's 35 feet away, we need to have 8-gauge wire to allow that fridge to run with only having maybe a 3% voltage drop associated with that. So I just want to make sure that when we're designing, if you are going to embrace some of that DC architecture, to think about how voltage drop starts to impact your systems. And that may be something that a lot of people on this call don't think about anymore because we're so used to doing AC only systems. But again, we're talking off grid, we're talking going back to the land and being a little more simple. So and I looked it up just before the talk. If we were to use a 48 volt fridge, which we actually did make near that, we had Tecumseh compressors that did 48 volts, we could get away with 12-gauge wire. Still not 14 though as well. So here's our system. Remember, we used 4 kilowatt hours a day. We had 19 kilowatt hours worth of batteries, 2,000 watts worth of Canadian solar panels. We're going to run all of those solar panels in series. So we build up the voltage of those panels to get high enough to make the MPPT charge controller in our charge controller or the charge controllers built into our inverter come alive as well. We're also going to add a generator to this one as well. Now, what I was talking about kind of was that still propane heat, still propane stove, still propane, other equipment. I honestly think that with the advent of cheap solar and the ability to provide reliable, safe batteries, we can do a more robust off-grid system and give people the luxury of what they're going to want when they're off-grid. Nathan, would you want to walk us through this diagram a little bit?
Yeah, sure. What we're looking at here is a Solar 15K. We've got DC coupled solar that's there. It's labeled as AC coupled array, but we've got DC coupled solar there with those are optimizers. Those are Solar optimizers, and I realize those are
coming out
not
still
out yet. Yeah, so Solar has delayed releasing those.
But those accomplish optimizing and your rapid shutdown capabilities.
Both in one. And yeah,
really
most optimizers do that. Yeah, exactly. Yeah. And, we're looking at a pretty big battery bank here. This is our Boss 12 cabinet. So if you do have it, you want to put our communicating amplify batteries outside. This cabinet is a NEMA 3R rated enclosure. It's a nice way to do that. Now, of course, if you're in a cold environment, you might not want to put those batteries outdoors, and you wouldn't need to necessarily purchase an enclosure like this. We're also looking at a big 22K generator there. And the Solar 15K has the ability to take in 19.2 kilowatts of continuous power from the generator port. And so, for an off-grid situation, many people, like Daniel said, would choose to have a continuous use generator there. And you might talk a little bit about our different generator options, Daniel, later in the talk.
Yeah.
Yep.
Thank you, Nathan, for running us through this. 15K, of course, everyone likes it because it has a 200 amp pass-through for grid-tied system, but it's a great system for an off-grid home as well. So one other thing that we might have a lot of people that live off-grid that already have a system, and now they want to replace some of those lead-acid batteries with our lithium-ion options as well. So a lot of times there were either flooded or gel cell or AGM batteries as well. If they're flooded and they forget to water the batteries, they're absolutely not going to last. And so a lot of these older systems still have parts and pieces like this Outback Radiant, those Outback charge controllers that are capable of working with our batteries. So what they did here is they took 16 of those lead acid batteries and replaced them with 5 of our 5 batteries. And this is what kind of the math looked like on that. Right.
Hey, Daniel, before you jump too far ahead, Steve Pitney made a good point here, right? He says, for off-grid, and I should have caught this, he says for off-grid, we generally bring our 26K generator right into the grid terminals. And in fact, I want to comment, off-grid, you don't need to use that generator port. You can actually use it for load shedding on a Solarc 15K because Solarc recommends that you bring your generator into the 200 amp gen port. So in an off-grid situation, We should probably customize that slide a little bit
Yeah,
for the soft
yeah,
grid talk. But thank you, Steve, for pointing that out. Daniel, let's get back to sizing.
that's a great point. 16 lead acid batteries. They were probably those Trojan 220 amp hour batteries. 220 amp hour battery at 6 volts is about 1.3 kilowatt hours worth of storage each. And if you got 16 of them, right, that's about 21 kilowatt hours. With lead acid batteries, really, we only want to have a 50% depth of discharge. Remember, I talked earlier about ours having an 80%. Lead acid batteries, usually this amp hour rating is at a 20-hour rate, whereas we actually can do it at 2-hour rate.
Well, actually,
Yeah.
the amp hour rating is good no matter the rate.
Okay.
It's the energy capacity that's affected by your rate of discharge. And the reason for that is if you discharge quickly, you get more of a voltage drop inside the battery. So you get less usable energy if you discharge your battery quickly. So good point. But yeah, absolutely. I mean, lead acid are not made to charge and discharge as fast as the lithium batteries are.
Yeah, but a lot of times we're not going to be discharging that quick or charging that quick anyway. So we'll kind of
Yes.
keep it apples to apples as well. So what you got in that battery vehicle was about 10 kilowatt hours of usable energy. Now we can come in with our batteries, and what these batteries are, they're 75 amp hours at 48 volts, and that comes out to 3.6 kilowatt hours. Technically, they're 3.8 kilowatt hour batteries, so the nominal voltage of the battery is closer to 51 volts, and you could say the same thing about the AGMs there as well, is that really it's not 6, it's greater than 6, but we're going to kind of keep the math simple for us. Each battery has 3.6 kilowatt hours times 4, that's 14,000 kilowatt hours or 14,000 watt hours. At an 80% depth of discharge, we get about 11 kilowatt hours of usable battery capacity. So you could take out 16 batteries, put in 4, and that last example we showed 5. There are a lot of calculators. Somebody asking earlier about that. There's that electrical load calculator that shows how to size the systems, and some of these other lead acid battery replacement calculators. There's a QR code there in case you want to leverage some of these calculators as well. It's also important to understand that a lot of people are going to say, I don't want, to replace those lead acid batteries with lithiums is going to cost a lot more upfront. And a lot of homeowners say, look, I just can't do it. I got to put the lead acids back. Try to have a conversation and sit down with the homeowner and say, look, although yes, the lead acids are going to be cheaper to replace, if we do come in and put in lithium ion batteries last a lot longer. You don't have to water them. You don't need ventilation for the hydrogen gas, and you can get more the lifetime cost of these lithium ion batteries indeed is better, right? How much is it? How many watt hours can you put into a battery? How many watt hours can you take out of a battery, and divide that by the initial cost of the battery as well. Some of those calculators show that. Again, Briggs Stratton has been around a long time. We have a history. We actually assemble the generators and the batteries here in the United States as well. We do both batteries and generators, so we're an expert in both. We have a great tech support and training team. Kudos to us, I guess, Nathan. And really, we're on the advancements of new future technical innovations. So when it comes to vehicle to grid, you better believe we're going to be there as those technologies mature. 15-year warranty on the SimpliPhi and SimpliPhi batteries. Those are the ones with the communication ports. Unlimited cycles, 100% depth of discharge with no throughput limit clause, right? So you can put in as many watt hours as you want, take out, and your warranty is just fine. Leveraging the lithium iron phosphate, LFP, that's pretty standard for the industry now as well. Remember, there's tax credits out there, and the 30% tax credit absolutely applies to off-grid systems. So when you're quoting these systems, and I don't want to be, deceitful, but when you show somebody the price of their system, show it after the tax break. And a lot of those systems like Aurora, SunGauge, Open Solar, they always bury the actual price kind of on page 6 of the proposal, and the price with the tax break there. But remember, there's also opportunities for other products as well, heat pumps namely. 4.98 battery, 6 kilowatt inverter. our Energy Track app. And again, Energy Track, we're going to be coming out with an upcoming training on this, but software is becoming so important to our industry. When we talk about vehicle to grid, we talk about a lot of these other devices, how and when these devices and storage components interact is all going to be controlled by software. And we're definitely leading that with our Energy Track app. Here's the battery lineup. The non-communicating battery on the left there, SimpliPhi and SimpliPhi battery, which are communicating there in the middle, and the SimpliPhi inverter on the right-hand side. Nathan does a great battery management system talk where we're going to talk into we'll get deeper into the whys and the hows of communicating batteries. Boss 12 cabinets, Nathan already showed us the Boss 12 cabinet that was in that larger Solar 15K system, but we also make a Boss 6 cabinet as well. Excuse me. This isn't off-grid. It could be a large off-grid system, but we definitely do have high voltage solutions where we take these same robust built in America batteries and kind of put them into a slightly different form factor in these server rack mount batteries. And then we can put these into a container and really meet large power requirements as well. I'm not the expert in this. If you are, let us know and I can connect you up with somebody who can answer some more of those questions. Remember, I said propane is the dirty little secret of living off grid. So I hope I don't get in trouble from that from the generator side. But these generators run on propane. They also run on natural gas as well. So these are historically, these have been called standby generators. And some of our competitors make standby generators, which means that they're only warranted to use in standby applications, like on grid-tied home. The power goes out, the generator starts up, you have a whole home transfer switch, and then you transfer over to the generator and transfer back. With the advent of energy storage and generators, and with the Briggs Stratton selling both of them, we can now combine these generators and energy storage systems like we would do in an off-grid situation and potentially an on-grid situation as well. And we do warranty our generators for off-grid. We have something that's called the NG Max, which means that a lot of times our competitors say they have a 22 kilowatt hour, a 22 kilowatt generator, but that's only on propane. As soon as you start running on natural gas, it derates. Ours don't. We call it NG Max. Again, some people call it prime power or non-emergency applications. Not all of our generators, but many of our generators have the certifications, the warranty to work off-grid as well. So we do sell packages to make this sale simple. This would be more applicable, I think, to grid-tied situations. But remember our off-grid situation, we had 5 of our Phi. You could theoretically use this package here on the far right, and they would just be sized for 100% depth of discharge. Even if you do cycle our batteries down to 100% every time, you're still going to expect about 3,500 cycles out of the battery. That's about 10 years worth of use if you're cycling it daily. Kind of wrapping up, we have an installation program. It's called the Elite IQ Installer Program. If you're out there installing batteries, please consider being part of this. We'll give you cash back per battery. We'll put you on the maps, and we'll send you some promotional items and also feature you then in our social media. If this is going to be your first time doing one of our systems, we're going to give you $1,000. Scan this QR code. Remember, if you're in California, we have opportunities to do SCHIP, and we have the California manufacturer adder as well.
Hey, Daniel, I wanted to ask quickly, Steve asked here, technically tax credits are only available for new full systems. Do you know what he means by that?
So I will say this, that I am not a tax expert. And I would, ask your tax provider. And I'm thinking I got to do my taxes because taxes are coming up quickly. But I do know this, that if you install a photovoltaic with energy storage system that is going to be providing power to a residence, whether it's on grid or off grid, you can take the tax credit. So I think maybe they're asking if maybe if you're taking out lead acids and putting in lithiums, can you take the tax credit? I'm not sure. I don't want to speculate. We're not tax professionals. talk to your tax professional and go from there. Anything to add to that, Nathan?
I don't, because I also am not a tax expert here. I do know that, battery only installs do qualify now as of the beginning of this year. Steve also asks about our industrial generators. So, if we have continuous duty industrial generators?
So I do know we get into what's called liquid cooled. All those generators that I was showing you, they're all air cooled generators, and then we do move up to what are known as liquid cooled generators. Email us. We'll put you in contact with some of our generator cohorts or people that kind of do more of the generator size. And they'll be able to tell you. But absolutely, we do liquid cooled generators, and those liquid cooled generators are a lot bigger because you have to have water pumps and radiators and heat exchangers all associated with it.
All right, thank you, Daniel. Do want to point out that one of the other things on the screen here, we're highlighting this Elite IQ Installer Program. There's a good financial reasons to join that. We know we're out of time. We do want you to check out our Power Academy as well, where you can learn about generators. You can learn about a lot of these things.
Absolutely. So let's finish it off for everybody. If you're here for NABCEP credits, email energystorage@basco.com, energystorage@Briggs & Stratton Company. That's what BASCO stands for. Please take a survey. We want to be better at these talks every time we give them. There's a QR link to take a survey and let us know how we could be better. Please say hello to us at NABCEP. If you come by the booth at NABCEP, say you were on one of these trainings, we'll make sure we get you a sweater, gloves, safety glasses, whatever it is to make you worth it. Nathan, as somebody who's lived off grid and somebody who has actually done the duty there, any final closing thoughts for us as we close out the hour?
I would just say it's a really fun topic, right? And there's a lot to be learned. And Daniel's going to send out this slide deck to everybody, and there's some helpful references he's put in here as well. There are pros and cons to doing many of these things, but I will say that our lithium batteries, especially our Phi batteries, are great opportunities for lead acid replacements, and they come with a really strong warranty backed by a long-lasting company. Georgie says, a great presentation, Daniel. So thanks so much, everybody. We'll see you at NABCEP. If you're going there, let us know. We'll bring you a hoodie. So send us an email, give us your size. We'll bring you a hoodie.
Thank you, everyone. Thank you, Nathan.
Bye.